Yeah, I think we can get started. I see Maji and Haley, they are online, and you can stop me anytime if I have any questions. I plan to go through the basic functionalities, and if you have questions, we can discuss the specific topic. Uh, so CLAMP, if you download CLAMP, it's a zip package. Just double click unzip and double click on the start CLAMP icon, run it. This is the default interface here. On the left side, we have all the resource, the machine learning resource and the NLP resource. In the NLP resource, NLP components, we have a list of these NLP functions. For example, the post tagging, the trunking, assertion. Assertion means detect negation from the clinical notes, and also attribute recognizer. This one is to recognize the like severity of problem, the body location of problem, or the condition of problem, things like that. So we can create a new project, create a new NLP pipeline here, and type a name. We will cover the Corpus annotation later. So we choose the NLP pipeline, finish, and then we'll have this pipeline project in the pipeline view. So if you double click on this component pipeline, you see it's empty right now. So we need to drag and drop from the NLP resource to the pipeline. For example, let me drag and drop the name entity recognition. This one is the one of the most important NLP component. This one will try to recognize all the important clinical concept from the notes, like a problem mentions, the treatment or test. You can drag and drop from here to the pipeline. And then now in the pipeline, we have one component here, but it has an error. Says if you want to run the name entity recognition, you need to keep drag and dropping more components. For example, the post tagger, sentence, all these dependencies. So what we can do is we can keep drag and dropping based on the error message, or try this autofix button. If you click on this autofix, CLAMP will try to fill in all the dependencies, solve the dependency issues. So by doing this, we have a fundamental pipeline here. So this pipeline from the break the nodes into sentence, and then break sentence into tokens, and then find the post tagging for each of the token. Post tagging means if a word is non-adjective or verb, things like that. And then the dictionary-based section header identification. This one would break the nodes into several sections, like diagnose section, family history section, and finally the concept recognition, the name entity recognition here. So once we have this pipeline ready, we can copy paste some data into the data folder. The data is just a text format, basically the TXT file. You can copy it from system or copy from other CLAMP project. Copy paste it here. If I double click on one, see that's a de-identified discharge summary here. So now the pipeline is ready, the data is ready, we can click run button. So when you click the run pipeline, it will start to process the file one by one. Initially, it will load all the resource into memory and then start the process. After that, in the output folder, we will have the XML file. If you double click, it will visualize the output. So in this pipeline, we only have one name entity recognition, and then it will output the problem treatment test, all these mentions. And then we have the TXT file here. In the TXT, that's a type delimiter format. So it has several columns. It has the start offset, character offset of a concept, end offset, and the tab of the concept. Now also have additional attribute. If you have the concept mapping, you will have a concept ID here. If you have the assertion in the pipeline, you will have the negation information here. But this pipeline, we stop at the semantic recognition. So all these fields are now for now. And then the last column is the entity itself. If we keep it drag and dropping into the pipeline, we may have more NLP functions. So we drag and drop this assertion and then run the pipeline again. Then in the output, we are expected to see the negation information recognized. You see, after we add the negation neg-ex component to the pipeline, in the output, in the assertion part, we can see if a concept is present or absent. And that's how to build a pipeline from scratch. And actually in CLAMP, we have the pipeline libraries. These are like the pre-built pipelines for a certain NLP task. For example, detect the smoking status from the nodes, or detect the bleeding mentions from the nodes. And also some general pipelines. The most comprehensive pipeline is right here, the CLAMP NER attribute pipeline. So when you have the clinical nodes, you can start with these pre-built pipelines to see if the pipeline from the library is it good enough for your NLP task. So we can drag and drop this one to my pipeline. Then it will create a pipeline project here. If you double click on the pipeline, you see there are about 20 of the NLP components. That's the most comprehensive pipeline. And then similarly, you can copy some nodes into this input folder and then run the pipeline, see the output in this output folder. So it may take a while to run this pipeline. I will just open the output directly. See, this is the output of the comprehensive pipeline. For the problem, it will recognize all these attributes like body location, negation information, and severity right here. And for the lab test, it will recognize the lab test value and make a connection between the lab test itself and the associated value. Yeah, so that's how to build the pipeline and how to use the pipeline library. So far, let me see, any questions? Okay. So next, I'll say all the components in the pipeline library that's customizable. Sometimes the pre-built pipeline doesn't run very well on your own clinical nodes. Then you can start to customize these pipelines. For example, let me open one. If you double click on this,
can I ask you a question?
Yeah, sure, go ahead.
Yeah, so when you pulled your library from, the existing library into your project, did it create a new project or did it add on to the project you had begun when you put the name entity recognizer in?
Oh, it's creating a new project. So if you drag and drop from here to here, you see It's a new project here.
I see. So you don't get an option to choose how that's named, or it auto names it?
Actually, if you already have one pipeline here with the same name, next time if you drag and drop, it will ask you to have a new name.
Okay.
Yeah. So by default, it will not replace anything existing there.
Okay, yeah, I
This
was
is
wondering about
already, yeah.
duplications.
Okay.
Okay, thank you.
Okay, sure. No problem. Yeah. So we are talking about how to customize a component. All these component is customizable. You have parameters there. You can fine tune with your own clinical notes. I will use this dictionary-based section identification as an example. If you double click, you see the option. The dictionary-based section identifier, it uses a parameter. That's a file called section map. And that file is in the attribute folder. Section identifier, dictionary-based approach, and then section map. If you double click on the section map, you see that's a predefined list of section names and the normalized values. So for example, sometimes they use the DS as a abbreviation for the section name. And if you see a DS in the notes, and then followed by some kind of rules to determine if it's a section header or not. If the result is true, it's a section header, then normalize the section type as a discharge summary. So you customize this one when you explore the output on your own clinical notes. If you see some section headers missing, then you can go back and customize on this section map file. And similarly, another example, let me use the negation, the assertion components as an example. Also, if you double click, it will give you the default negation dictionary here. In the dictionary, you see all these negative words, phrase listed. And there are different types. The negation phrase, that's the word before the concept. The patient denies something, that's a negation phrase. And also it has a post-negation phrase. So it says something is unlikely. That's the negation phrase, but it's after the concept. And also has defined some conjunction structures. Yeah, and also has some pseudo negation phrases. So it has the negation word, but actually that's not a negation. So it's like when you explore the output on your own clinical notes, you see a concept that is negated, should be negated, but not recognized by CLAMP. Then you can go back to the negation assertion, the negation component, and then customize the dictionary here. And that's how to customize dictionary. And another example is here, the name entity recognition. So this one, you see a parameter that's actually a model file. This is the machine learning based name entity recognition. It will recognize all the concept from the nodes. The concept actually defined in this model file. And this model file, you cannot simply edit it, but you can generate this model file with the Corpus annotation and the machine learning training. So in CLAMP, we have the Corpus view here. This is a place where you can annotate your own corpus and then build the machine learning model. So let me show this part. So if you want to recognize more, not only problem treatment tests, probably you want to, in your own p-task, you want to recognize other things like maybe the gene name or the chemical name, it's not covered by the default CLAMP components in the models. In that case, you can go to the corpus annotation, start to annotate your own corpus, and then train your own machine learning model to recognize that. So let me type in here. Similarly, you go to this new project, and this time choose corpus annotation, define a name here, and then you see the corpus project. The folder structure is different from the pipeline. In Corpus project, we have this type define XML. The type define, that's a place where you can define all the semantics you want to annotate. And it has two categories. One is define the entities. So here we can define anything you want to annotate, maybe gene name. And you can define more like problem or disease or something, and body location. So actually in this type define, you can add a subtab. If that's a problem, maybe you can define a subtype of this problem, maybe diagnosis. So basically you can define a tree structure in the entity part. And then next, you can define relationships. So in relation, say add a new relation tab, right click on this relation, say add a new relation tab. Then it will give you the dialog like this. So what is the name of this relation? We can say it's location of, and then from entities. That defines what kind of entity could this relation come from. So we define a location of. From entity, we see it should be from the body location. And the two entities actually, you see, can be body location of a problem or body location of a specific diagnosis. So you can define something. And then in the relationship, you have a location of relation from body location to either problem or diagnosis. So after define this semantic information, next step, it can still copy paste some nodes into the training folder. Let me copy paste something from our side. Again, the input nodes is just the regular text file .txt. Copy that, paste it here. And this time, if you double click on the text file, I will convert the text file into XML format, based on which you can start the annotation. So yeah, I'll just randomly select something to show the annotation function. If you select your word, it will give you a pop-up menu here. Say this one is a problem, and then maybe select something else. Say this body location, and keep doing this on the whole document. That's the annotation for the entities. And then for the relations, you click the body location, drag and drop to this problem. It will give you the relation options, say that's a location of. Yeah, that's how to define semantics, annotate, and then create relations. So in the practical task, you keep doing this on the whole document, and maybe after you have maybe 100, 200 of these nodes, you can start to train the machine learning model. Okay. So any questions before I show the how to train machine learning model? Any question about the semantics, the how to annotate entities, relations? Yeah, you can type the questions in the chat box if you prefer. Okay. Okay, I'll go ahead and show how to train machine learning models. Let me close all these. So this is one note. I will show that on some existing annotations. No, this one. Okay, this one's good. So I will show that in a really straightforward task. So in this annotation project, I'm just trying to annotate all these semi-structured informations like the item header. Annotate all of these from the nodes. So sample name, description, date of emission, date of discharge, all these item headers annotated. I want to train a machine learning model to recognize these item headers. So this is quite straightforward. We can go with dictionary based, but we can also use a machine learning for this. So this task is easy. So we don't have to annotate lots of the nodes. Maybe 10 or 20 of the training sample is enough to train a reasonable performance the machine learning model. So I have 8 of the nodes here, all the item header annotated. And the next step, I want to train the machine learning model. So to train the machine learning model, select the training folder. Select this train folder, and then go to the icon here. There's a train model icon. So click this train model, and then it will give you this big dialog to customize the machine learning model training process. You have a model name here and the location of the training corpus, and most importantly, the feature selection part. So we are using the CRF as a machine learning tool in the backend. The CRF, they will require the features created by domain expert. So here we have a list of these features. These features are proved to be effective on the clinical notes. We use these features a lot in these NLP challenges. So generally, if you select them all, you may achieve a reasonable performance on the clinical notes, but you can also try to customize these features. For example, maybe you can use a subset of these features, see it can perform even better than use a whole set. We have a documentation about all these features. In here, let me just use one, the worship feature. So these feature engineering, any questions?
There is any option to add a new ones?
Yeah, that's a good question. That's actually, yes. So to add a new features, you have to use the CLAMP NLP as a library and then write some Java code. Let me show you one. The configuration, if you open with a text editor, you see actually that this feature extractor, that's a Java class. And these is the parameters defined in this Java class. So if you add the CLAMP NLP as dependency and follow the type definition, I mean, extend the basic feature extractor class, then you will have, and then create a configuration like this. Then next step, you can add the feature extractor into this folder.
Okay.
Yeah.
Thanks.
Sure. Okay, let me show the dialog again. Yeah, like I mentioned, these features are designed for the CRF toolkit, the CRF suite we are using in the backend. And we are also working on a deep learning solution. In the deep learning based class, the name recognition, we don't use any of these human created features. We just use the word embedding and the deep learning algorithm, and then run the prediction, train the model and run the prediction. That will be in our future release. I call it CLAMP 2.0, and this one is 1.5. So that's the feature part. And then we have the CF suite options, but I disable here. I can enable it if you need. This is the parameters at the machine learning toolkit level. You can fine tune these parameters. For example, the C2, you can use maybe a 0.8 or 1.0 to see if there are further improvement. And also have the evaluations. In the evaluation, you can use an individual test set, or you can use cross-validation on the training set itself. So the cross-validation is like you split the training samples into several pieces and then use one of them as a test set and the remaining as a training set, and then repeat that several times. You will get the cross-validation result on the training set itself. So once everything is configured, say finish, and oh, it's already finished. And then you will see the training information from the console output. It's running the iterations in the CRF toolkit. So once everything's finished, then go to this model folder. This is the model we just trained. And it has several files in here. There's a feature file. And if you're familiar with the machine learning, you can explore the feature file. Actually, that's quite straightforward. The first column is a BIO tag for the sequential labeling task, and then all the following columns is just a feature string itself. And then we have this training log. In this training log, it has every information about the training process, how they display the training fold. And then to the end of this file, we have a summary of the results, the accuracy. You see, after full cross-validation, we have the summarized result, the precision, recall, and F-score of the atom header recognition. Like I said, this task is quite straightforward. So even if you only have 8 training samples, the performance is still quite high. And then we have these model files. That's an individual model file for the unfold, and also have this model file. This model file is the final output, like after the machine learning training process. So with this model, you can copy this model and then go back to the pipeline where you want to apply this model, and then copy paste it here, and then in the configurations, so now it's using default model, right? You can click and then change it to the new model. So now in this pipeline, in the name event recognition, now it will not recognize problem treatment test anymore. It will recognize the atom header based on this model we trained in the Corpus annotation part. And then we have go back to the Corpus part, we have the output folder. So during the machine learning training process, sometimes you get the performance, and then the performance is not very high. Then you want to see if there are patterns of the error or something, how to improve the model. And the output folder, that's designed for the error analysis. So in the output folder, if you click any of these output, you see the result is visualized like this. So the gold standard from the human annotation is listed here, and also the prediction from the machine learning algorithm is also listed here. That means if you see a completely overlap between the human annotation and the machine learning output, these are true positives. The machine did a good job. And then if you review it, see here, the human annotate this one, the whole date of the discharge as an item header, and the machine learning prediction made mistakes. It's saying the date of is a one item header and the predict is another one. That's an error of the machine learning algorithm. So see if other examples. Yeah, and this one annotated by the human expert, but actually the machine learning doesn't predict as a item header. The machine miss it. So in this case, the machine makes some mistakes. Then you have an idea, and then you can go back to the feature engineering part, see how to customize the features and predict more clues to the machine learning algorithm, and then improve the performance. But sometimes you see, it's not shown here, but actually sometimes you will see the machine learning actually did a good job, and the human annotation, the annotator, they make mistakes. In that case, you can go back to the Corpus annotation part and update the human annotation based on the machine learning output, refine the training corpus. So yeah, that's the whole workflow about the develop the machine learning models. And once everything is finalized, like I demoed, you can copy the final model to the pipeline, apply it in the pipeline. So any questions, feedback about the machine learning model training part?
For the relation extraction, what algorithm you use?
Relation extraction in the software, we're using the SVM-based classifications. Basically, first to generate the candidate pair of the relationship, and then run the prediction, see the candidate is true or false. If the prediction is true, actually there's a relation between the items in this pair. If it's false, there's no relations. So like I said, the deep learning solutions, we have some code, but it's not in the software yet. Okay. So yeah, I demoed how to train machine learning model, how to build the pipeline. And once we have the NLP development finished, or the machine learning finished, or the pipeline finished, next step will be apply this pipeline, run on a really big database to process the real world data set. So for that, the GUI is designed as a development environment. So you can customize the NLP component, train model, annotate corpus. But once everything is finalized, you want to run on a large data set. So in that case, don't use the GUI anymore. We have the command line version designed for that. So you can export the pipeline as a jar file. Right click on this component folder, export as a jar file. So with this jar file, you can run it on the command line version on the Linux server, connect to database with different I/O options, or things like that. So can copy this one and then run it with a command line version. Let me see if I have command line version. Yeah. So here's the command line version. It's also available on the CLAMP website. The command line version, that's a zip package, that's a folder structure. In the command line version, the first time you download command line version, you run the activation. and then input your email address and the SN number from the CLAMP website. And then we have several launch scripts, the BAT script for Windows, the SH script for Mac and Linux. And if you open it, you see that's basically a simple setting of the Java command. In the setting, if you are running with the UMLS encoder, basically want to map the concept to the unified medical language system, the UMLS ID, then you will have to maintain your own UMLS username and password. You can apply the account from the UMLS online website, and then set the input location, output location. That's a folder, the whole path of the input and output folder, and then the binary, and then pipeline. So this is the pipeline. This is the place where you can use your own customized pipeline. In this one, I'm using medication attribute something. You can replace this one with your own. You just the one you just exported, and meanwhile you can copy paste that pipeline in the pipeline folder. This is a pipeline we just exported, and then set the correct pipeline name. And then you can start to run this pipeline. Yeah, run this SH script like the normal bash script. We have another one here. Yeah, it's kind of similar. So for the command line version, oh, I don't have output here. The output is similar like what I showed in the CLAMP GUI. Basically, I will also output two candle files. One is the type delimited format. Yeah, one is this format where you can copy paste to Excel or export the database directly. And the other one is the XML file. Basically, it contains every information about the output. So yeah, that's how to run the command line version. And for the developers, we have the.
Can I ask a question about the command line?
Yeah.
So for the input, can the input be like a query from SQL? So and then read the data from SQL directly, not store it in the file first and then run?
Yeah. So you can use the JDBC to connect CLAMP with the database and then read from database directly. And for the output, I think there are options to output into the file format or write to database directly. It's not included here, but I can provide you an example about that.
Okay, then probably we can talk later then.
Yes, yeah.
Thank you.
Sure. So I showed the GUI, the command line version, and then here is how to use the CLAMP as a library and call everything from the API on the API level. So like I demoed, every ampli function available from the GUI, it's also available from the API, the code. And I have some very simple demo here. Basically, you download the CLAMP NLP, use that as dependency, and then you can start to use all the API here. This one is showing how to extract all the information from the XML file. Basically, it's like you knew this one as a CLAMP document and then get every information from the document API and get sentence, get entities, get relations, all these things. And another example is how to use the function itself from the API. The sentence detector, tokenizer, you build the pipeline programmatically. Say for each content, detect sentence, and for each sentence, detect tokens. So we have API for all these NLP components. If you want to, develop based on the CLAMP NLP. Yeah, so that's pretty much all about this demo. Any question, discussion?
Thank you very much. I appreciate this.
Yeah, thanks, Edie.
Thank you.
Sure, welcome, Majid. So yeah, give me a message if you have any problem or issues or suggestions with the CLAMP software. Okay.
Will do.
Okay.
Bye.
Thank you. Bye.
Thank you. Bye, Majid.